Given y equals to ln x plus 1 over sed x, show that dy dx equals to 1 over sed x times 1 over x plus 1 minus ln x plus 1 over 2x. So let's copy down the question. We have y equals to ln x plus 1 over sed x. So for this question, we're going to use quotient rules because we have a function in terms of u over v. It is a rational function. Now, to differentiate u, we're going to use natural log rules, which is differentiate the function and copy down the function. That is how we differentiate natural log. And for v prime, we're going to use power rules because we have functioned in the form of power, where we're going to bring down the power, copy down the function, and the power minus 1. So this is our plan. So now let us write down what is our u. U equals to ln x plus 1. Now if we differentiate our u using the natural log rules, we're going to differentiate the function. So if we have ln x plus 1, differentiate x plus 1, we're going to get 1 over, and copy down the function, we're going to copy down x plus 1. Now let's take a look for v. Our v is sed x. So we know that sed is the power of 1 over 2. So if we use the power rules, so we're going to differentiate as bring down the power, which is the power is 1 over 2, copy down the x, and the power minus 1. 1 over 2 minus 1 is negative 1 over 2. Let's rewrite this as 1 over 2 sed x. Now we can use the quotient rules to differentiate our y. So differentiate y is with respect to x is dy dx equals 2. And if we use the quotient rules, we know that the quotient rule is vu prime minus uv prime over with v squared. So our v is just now is sed x times with the u prime, sed x over x plus 1 minus the u is ln x plus 1 times with the v prime ln x plus 1 over with 2 sed x. There is over v squared, and our v is sed x. So sed x squared. Now, let's think what we should do next is we have a double fractions here, right? This is a fraction and this is another fractions. So we cannot leave our answer in double fractions. So what can we do here is let us take a look of this. What happened if we do sed x squared is we're going to have x, right? And as for sed x over x plus 1, leave it like this first, over with 2 sed x. Now we're going to get rid of this x by multiplying 1 over x in the numerator and denominator. So I'm going to put a bracket here. So what happened now is there's no more denominator here, there's no more x here because we have already times x with 1 over x. It become 1 now. Okay, so I'm going to write down my 1 over x here and times with this set x over x plus 1 minus ln x plus 1 over with 2 set x. So what's next is I'm gonna times my set x over x plus 1 with set x over set x. So I'm going to get 1 over x set x over x plus 1, going to multiply this with set x over set x minus ln x plus 1 over 2 set x. Now let us simplify what happened. Set x times set x is x, divide with set x times with x plus 1 minus ln x plus 1 over with 2 set x. Next, I'm going to distribute my 1 over x to each of the terms here and here, and on the same time I'm gonna factorize my 1 over set x. So I'm gonna get 1 over set x. Now I factorize 1 over set x, and if I multiply or I expand, it become x over x times x plus 1. You may think it as you exchange it, right? It's almost the same thing. Ln x plus 1 divide with 2x. So I can simplify this x and this x, become 1 over set x times with 1 over x plus 1 minus ln x plus 1 divide with 2x. So let us take a look again what the question asked to prove. dy dx equals to 1 over set x times with 1 over x plus 1 minus ln x plus 1 over 2x. So this is shown. That's it.